I'm going to walk you guys through this one, all right? Let's look at this first one. Can I rewrite this base right here, the 81, so that it has a 9? Can I rewrite 81 as a base 9?
Yes.
Okay, what is 81 as a base 9? What would the exponent be? It would be a 2, right? So I could say 9 to the second power, and that would be raised to 0.5t plus 0.25. Okay. Oh, man. This is crazy, guys. We have to go backwards. We're going to go backwards. Okay, so what do I mean when I say go backwards? Okay, I'm going to write this really fast so you guys know what I mean when I say go backwards. If I go like this, x to the 5th, what's another way? Actually, no, let's go like this. X to the 5th plus y. What's another way? No, that's not going to help you guys. Let's do this. Let's go forwards. X to the second times x to the third. What would you get?
X to the 5th.
X to the 5th. All right, you guys are good at that. Okay, so here, about x to the second times x to the y. What would that be?
X to y.
No, not x to y. What'd you do with these to get 5? You added 2 plus y. So if I go like this and I start with this guy, I say, what's another way we can write this? What would you say? X to the 2 times. Right? You guys got that? So that's the backwards I want you to do with this one. So how can I rewrite this one?
9 to the 0.5.
Okay, well, actually let's distribute this 2 first. Well, this is she said no. All right, this exponent right here is a parenthesis exponent, and what you do is you multiply it to the inside exponent. So if I did that, if I multiply this 2 to these guys right here, what would you get? It actually cleans up very nicely. It'd be 9 to the, what is 2 times 0.5?
1.
Is it? It's just 1. So it's 1t. So I'm going to put a t, which is what I heard some of you guys saying. And what is 2 of those?
0.5.
0.5, so 0.5. Okay, so now I don't see this over here, but I do have a 9. So we're on the right track, right? I hope. Okay, so I have that 9. Now, can I rewrite this by using this concept right here? How would you do it? It would equal what? 9 to the
9t
t times 9 to the 0.5. And what is 0.5 the same as? So I could write 1/2 right here. Maybe that's nicer. Do you guys know what 9 to the 1/2 power is?
4.3. No, 3.
Is it?
No, it's not 3.
Let's see. The 1/2 power is the same as the square root, right? What's the square root of 9?
3.
Hey, so this one's equivalent.
Wait a minute. You back.
Now the next one, it's a little hairier. Okay, so I'm looking at this going, the bottom and, the denominator and the numerator both have the same power. So I can technically write this as 27 over 3 raised to the t plus 0.5. And so I could take the exponent out of this and like have the parentheses. Do you guys know what 27 over 3 would simplify to? 9. Whoa. That simplified. No way. So it simplifies to 9 raised to t plus 0.5. Haven't we seen that somewhere around here? Yeah. Oh, snap. It's right here. So is this one equivalent to this?
Yeah.
Yes, it definitely is. Wow. Okay, so that was a crazy trick that I did right there. Do you guys know where I got that from? You guys remember, maybe you guys have never done this before. If you had, let's say, a 2 over 3, and you were raising this to the second power, do you guys know how you would do that? I mean, there's a couple ways you could do it. You can go, 2 over 3 times 2 over 3, right? That makes sense because, it's twice. It says 2, so you can do it twice. Okay, well, there's another way you can look at this. You can go, that's a parenthesis exponent. And what do you do with parenthesis exponents? You multiply it to all the inside exponents. So this 2 has a 1, and this 3 has a 1. And so if I multiply this 2 to the inside exponents, I would get 2 to the second power and 3 to the second power. And so this is kind of what I was thinking of when I was looking at this guy right here. I was like, hey, they both have the same exponent. I could put parentheses around this diggity dog. And I could take that 2 out. 2 over 3 raised to the second power, which brings us right back to where we were. But that's what I was thinking. And I know, it takes practice though. So let's look at this last one. Is that one equivalent? Like, I don't know. The other two I thought was no, but now... Okay, now I kind of want to consider something here. Like, okay, this guy... All right, so they both have the same exponent again. Is it possible for me to take out that exponent from both of those bases? Yeah, so can I write it as 27 times 3, and then they have the same exponent, so 0.5t plus 0.25. Do you guys know, okay, this kind of looks like this guy right here. But that would only be true if 27 times 3 equals 81. What do you guys think? Does 27 times 3 equal 81? Oh, snap. It does, I think. Let's see. 27 times 3. 27 or 7 times 3 is 21. And then this is 6, right? 3 times 2 is 6 plus 2 is 80. Oh, snap. This is 81 right here. So this is also equivalent. Now, I think by far this is going to be the hardest one because it has decimals, you know? So I got a question. They're saying, like, how do you know this right here is equivalent to this? Well, at the very beginning, I manipulated this a little bit because I saw this first one, right? I was like, all right, can I get a 9 out of 81? And you guys were like, yeah, we could totally get a 9 out of 81. And then we wrote this. We went 9 squared because that equals 81. Remember that? So this right here is the same as this. And then we went even crazier. We're like, okay, let's get rid of this 2 right here because I don't see a 2 on this 9 over here. And we distributed this 2 to the parenthesis exponent, which is this nasty, ugly looking thing. You know, it's kind of like, you know, your face when you wake up. And so I distribute the 2, and then I got this. And this is what this is. And so this is equal to this, which is equal to this. That's how I knew. Good question.